Okay. Okay, let's get started since everyone that's been in the waiting room has been admitted. Welcome to today's Toolbox Talk series session brought to you by the American Bar Association's Division One Dispute Resolution and Litigation Division. My name is Kenita Williams. I'm chair of the Toolbox Talk series committee, and I'm a member of Division One, and I'm a member of the Division One steering committee and a 2022 diversity fellow. Today, we're going to have a very interesting discussion. Today, we have guest speaker David Schnerch. David Schnerch is Principal Senior Engineer and Building Science Specialist with RDH Building Science, Inc. out of Boston. And a little bit about him. He's currently Vice President of the Structural Engineers Association of Massachusetts, and he was previously President of the Boston Association of Structural Engineers. And he has over 20 years of experience on over 1,000 projects as a consulting engineer. His work primarily involves problem solving and failure investigations of building structures, facades, and building materials, including primary structure, cladding, and interior finishes. And so we're happy to have you here to discuss preserving evidence after facade failure. Without further ado, if you please. David.
Thank you, Kenita. And here's my information. I'll go back to that slide towards the end if there's any questions following the presentation that anyone needs to reach out to me at. So I think I'm just going to jump right into it. I think one of the issues with documenting facade failures is that we have these kind of three components that we're always challenged with, and one of those is time. Very often these events may happen suddenly. If it's a collapse type of failure, there may be a desire to reopen the site or move materials. So we're limited by in the time that we can collect information, and we're limited also potentially by other parties that are involved in collecting that information as well. Well, one of the other things that we're challenged by is the vantage point. You know, we're dealing sometimes with large structures or tall structures. You know, reviewing conditions from the ground may or may not be suitable, depending on what type of failure we're looking at. And then the third thing is the data management aspect. We're collecting very often large photographic data sets. Sometimes there's video, sometimes there's other kinds of documentation that we're collecting. And these kinds of data sets don't necessarily play well together. So means by which we can synthesize the data while we're collecting it is really advantageous. So when we're talking about failures, you know, obviously, first thing that comes to mind maybe is collapses, but there's also other kinds of failures, and that might include air or water infiltration. That sometimes happens with newer buildings where either materials weren't installed in the correct sequence, or there's other issues with the assembly or the construction. We have problems where there's issues with condensation, where there's excess humidity in the building, or cold temperatures on surfaces where that condensation, water or ice sometimes isn't desirable. And we also have situations, particularly here in Boston or other urban areas, where adjacent property owners are working next to each other, and sometimes the contractors may have issues performing work in a safe way that doesn't damage adjacent buildings, or there can be issues with the below grade conditions that also cause issues. So the first thing I'll talk about is visual documentation. That's really oftentimes our primary means of documenting conditions. And I'll talk about three different areas within the visual documentation range. One is photography, panoramic photography as a subset of photography, and also construction cameras. So photography has significantly changed from the use of film-based cameras, which were pretty much prevalent when I started my research career, and towards the end of that, things were moving towards digital photography. But now we're in a space where there's much more computational photography. So when we were dealing with film-based images, like the images I'm showing on the screen right now are pretty consistent with what one might capture with a film-based camera. Whereas now when we're dealing with computational photography, we may be taking multiple images and combining them digitally into a single image to provide more detail, provide a wider range of view, or to provide an exposure that's more consistent with the way we see things with our eyes. This is really blurring the way that pictures are being considered, because as we know with AI and all these other things, we can't necessarily rely on a photograph in the same way that we might have in the past. So one of these means of computational photography is what's called high dynamic range photography, or HDR. And in this case, we're capturing multiple images of different exposures to get a scene that has the correct exposure. This can occur, or this can be needed in places where there's high contrast due to high amounts of sunlight or other lighting conditions, or conversely, areas where there's contrast due to shadow or inability to light spaces. We also have other means of computational photography in terms of capturing these large 360-degree images. Oftentimes when we're on a site and we're investigating a problem, we may have limited time to inspect things. So there's a desire to be able to capture a large or complete view of our surroundings. And the top image shows one situation where we captured the entirety of the facade and we're projecting it into a single photograph, just like if you were showing a map of the Earth or a map of the globe and projecting that into a 2D map, things get distorted. But now we can also, using the digital means, recompose the figures so that they're prospectively correct. And so the lower figure shows that area in the yellow box on the top figure where that photo has been recomposed. So the question comes into play is, how do we provide this photograph to others? How do we share it? There can be proprietary information in the top picture, which may not be readily accessible to other parties. And, do we consider this one photo, two photos, or, I would really consider it kind of an infinite array of photos where if you had access to the top photo, you could recompose it in multiple different ways. And then going back to our viewpoint challenge, one of the real game breakers is this movement to the use of small unmanned aerial systems, or what they're commonly called as drones. And drones allow us to easily access spaces that were really not accessible by any means other than chartering a helicopter with a photographer. And actually, use of drone is actually much better than that, because we can get much closer to the building and we can do it in a way that is much more convenient and practical. Conversely, though, we do have issues where most of the drones that are being used right now are produced in China. There's definitely privacy potentially concerns, because some of the data can be shared in terms of where that drone is flying and what the camera is seeing as the drone is flying. We now have flight automation software as well, which allows us to almost scan a building in a sense, where we can set the limits of a facade and the software will automate the flight path for the drone so that pictures are taken at intervals along that flight path. This allows us to make sure, again, similar to the 360 camera, we're getting a comprehensive inspection that includes all portions of the facade that we want to capture without missing anything, and in a process that's also repeatable. When we're documenting things with drone, we have to look at the resolution. We have to look at how close the camera can be to the facade safely in a situation where flying the drone, it's subject to wind or other conditions. Higher resolution requires us to be closer to the surface of the building, or conversely, to use a higher resolution or a zoom lens on the drone. Both of those things require longer to take, but we also ultimately have to think about what kind of deficiency are we looking at on the building, and having enough resolution to be able to capture that deficiency. And this type of inspection, visual-based inspection, doesn't necessarily replace the need for hands-on inspections. And hands-on inspections can be particularly relevant where we're looking at buildings where there's multiple layers of an assembly, and the portions of the assembly that are contributing to the problem are actually beneath the surface, and we can't actually get to it without some disassembly to allow that to occur. FAA controls all the airspace. There's means of requesting airspace authorization, both spontaneously and also through this process of a certificate of waiver. In general, where this is more of a concern is where we're flying the drone near airports. Obviously, we can't have the drone being in conflict with any manned aircraft. One of the other techniques that I've used in the past that I've found relevant is robotic panoramic photography. And this is something that the name may not be familiar to you, but if you've seen any of the photos of the Mars landings, they were using this technique to be able to capture information of the surface of Mars. And one of the advantages of this, like I was saying before, where we have these large data sets, the top right image is one portion of the facade of a building. This is actually a photo mosaic where it's actually produced out of, in this case, about 14 or 1500 individual photos that are all blended together into a single photo. The advantage of this is we don't have to go through manually those 1400 pictures. We can basically scroll around on the facade and get to the particular areas of concern in a very detailed kind of way. And then thirdly, construction cameras. And I'm often surprised at how often now, more so than at the start of my career, people are taking videos or images of buildings all the time, either when they're being constructed, such as in this case that I'm showing, where OxBlue cameras were showing the construction of a building, or in other cases where there's other sources of images that have gone through social media and things of that nature, where it's showing either how the building or the facade was constructed, or showing how the facade existed before whatever event or problem occurred where it became necessary to perform this other investigation and ultimately correct the issue. So those are all means by which we're using photography and images to capture visual information. These next two means of capturing information are also, to a degree, allow that same kind of visual information to be documented, but in this case, it's supplemented by spatial documentation. And these are LiDAR and photogrammetry. LiDAR uses reflected laser light to document the space around the LiDAR equipment that's being used to collect that data. And essentially, it's sending a laser pulse to the surface, and it's sending that pulse tens of thousands, hundreds of thousands, or even millions of times. And it's just sending that pulse back, getting the reflection, and it's identifying where that pulse is being reflected in terms of XYZ space. So we have a coordinate system in 3 directions or 3 orientations. And it's also determining the color. So we get some visual information from that reflection, and the intensity. So also light and dark. And by using the LiDAR, it's very useful when there's a situation where later on we may want to take measurements that we can't get because materials are being moved, or there's conditions that are changed in a way that those measurements will no longer become available. Based on the use of the LiDAR, we can keep that information basically as in perpetuity. We have that virtual space where that LiDAR equipment was recording that data. It's important to realize that LiDAR can't see behind objects. So one of the things that's done typically in this type of scanning is the device is moved from location to location, and you're again kind of stitching rather than particular images. In this case, you're stitching together those 3D point clouds so that you can develop a space that doesn't have these kinds of shadows, and you can capture other surfaces behind where the LiDAR device can't directly see or get that reflected signal back from. LiDAR is very important in situations where we need to do some analysis based on the size, the weight of objects, or in cases where the tolerances of surfaces or the tolerance of subassemblies is important in dictating how flat a surface is and how flat that surface is relative to standards and specifications related to how flat it should be. Photogrammetry now is being used more and more to also generate these types of point clouds. And whereas in the past, we had to use very sophisticated $100,000 equipment, now pretty much anybody can do this kind of photogrammetry with a phone. And there's software available now where multiple images are collected together, and based on how those images overlap and particular features on those images, the software is able to get for us the similar kind of information in terms of spatial information as to where those surface features are and how those features relate to one another. So it's really trying to do the same process as developing the point cloud with the LiDAR, but it's doing it in a way that it's using images. And in some cases, if you have a very good photo set, you can do this kind of photogrammetry after the fact and not having planned to have done it in the first place, which is also something that's changed in the last few years. Other data that we're capturing for other types of problems is vibration data and temperature humidity data. Vibration data is particularly needed in urban areas, again, where we're dealing with facades next to new construction. Oftentimes, what we can do is either set up a seismograph before the construction activities begin, record that seismograph on a continuous basis while those construction activities are occurring, and verify whether or not the vibrations are occurring at or below a level that would be expected to cause damage. Conversely, if seismographs aren't recorded during construction or within the adjacent property owner's property, oftentimes those seismographs may be located on site, and there may be other sources of vibration data that we can review and evaluate that data based on the activities that occurred at the time, in conjunction with any damage that occurred during that period. Definitely, it's preferable though to install this type of equipment prior to construction, because unlike photos and videos, it's a lot much more unique kind of data collection. And then temperature and humidity, it's interesting because this has some overlap also with the drone use as well. Very often we're using IR cameras, infrared cameras, to determine the temperatures of surface. And by understanding the temperatures of a surface, you can begin to understand either air leakage through different gaps or joints between materials. You can also infer moisture conditions below materials as well. So the use of the IR camera is non-destructive. It doesn't damage the surface, but also it's desirable to verify what the IR camera is telling you, just like any other kind of non-destructive method. It's an inferment, but it's not necessarily telling you exactly what's happening beneath the surface. So it can help you though to locate where you might want to make inspection openings or do other measurements of temperature or moisture. The other thing that can occur as well is with various sensors. We can install these sensors into wall cavities or on surfaces. And for situations like condensation, that can be helpful in the evaluation process, because we can assess the temperatures of the surface relative to the temperature and humidity conditions of the surrounding air, and that can help to assess the cause and responsibility of those kinds of issues. I'm not going to touch about it very much, but sample collection is obviously an important tool as well. The types of samples that are retained are very widely varied, and the procedures used to collect those samples will also be varied depending on what materials you're trying to collect. In this case, I'm showing two images of coatings, and coatings very often are looked at in the lab to identify the thicknesses of the various layers of the coating, whether there's pinholes or other defects in the coating that could be responsible for blistering, peeling, or other problems. When we're dealing with building materials, we always have the challenge of collecting enough samples to be representative of the range of conditions on the building, because collection of samples can be very time-consuming and costly to do. So there's always the question of, what is a representative sample, and do we have enough of that sample to say that we have a representative sample? So in summary, I think the key takeaway I would suggest is that there's a wide variety of means of documenting conditions, and it's important as much as possible to think about not only what your first inkling is or what your first hypothesis is of why something occurred and who's responsible for it, but to try to understand all of the hypotheses so that you can go ahead and have the information available to prove or disprove those hypotheses as you need to. And very often at the outset, we don't understand very well what the actual cause is. So making sure that we have a very comprehensive data set is important so that we can perform that analysis. So with that, I will conclude, and I think we have a few minutes for some questions.
Very interesting information. Those are some very powerful tools that you utilize to collect data. Something that I was thinking about as I was listening to the presentation is, it sounded to me like some of these sensors and some of this data can be sort of collected throughout the lifespan of a building. Do a lot of the newer construction have things like, for example, sensors for vibration levels, and maybe they can detect if there's like a dangerously high vibration level in advance and do something about it?
There's
Mhm.
there's certainly more and more of the industry is definitely going to that way, and you know, if you're familiar with the internet of internet connected devices and things like that, there's certainly more data being collected in terms of you know, floor by floor data for larger buildings or space by space data. And you know, it's actually kind of surprising sometimes how much data actually is available that you think that you might not appreciate at the start of a project. So I would say yes, and I would say in the future there's going to be more and more of that data being collected.
And so I presume when you get retained on a case that and that might not be the first step, but I would think one of the first steps would be appreciating what data is available and collecting that data, preserving that data as soon as possible. Is there sometimes just overlap? How practical is that? How much are you duplicating data and, you know, getting information that may already be available?
Well, I wouldn't say there's necessarily a lot of overlap, because I think a lot of times we're collecting, it might seem like we're collecting a lot of data at the outset. We're, you know, trying to gather as much as we have, but it usually turns out that ultimately a very small proportion of that data is useful, but you kind of need to catch, kind of need to have that wide net to be able to catch what you need. So ultimately, a lot of that data you won't find useful, but it doesn't really take, if it doesn't take additional time and you're not spending time evaluating it, you know, I would suggest it's best to have that data than to not have it. Because sometimes, like I said at the outset, you don't necessarily know exactly what you need.
We have a question from the audience. Have you had the opportunity to see any of the information presented to a jury? And are there methods that are easier for lay people to digest?
Well, certainly, you know, the saying a picture is worth 1,000 words is very true.
Mhm.
Um, you know, I think now with the, you know, we have these tools that, you know, not only can we capture visual data, but, you know, by capturing it in a way where we're using LiDAR or the photogrammetry method, we can actually spin around that model and have that model in a virtual space where we can maybe overlay the infrared information on top of that to really paint a very detailed picture of what we're trying to describe. Because often, as you know, there's a lot of complexity to these types of problems, but being able to present it in a way that's easily understandable and compelling can be very useful.
We have one more minute. The other question I had was just when it comes to using the drones, how do you limit what's captured to make sure that no one's privacy is violated? Or is everything captured and just redacted? What are the rules governing that?
Well, it's the airspace above buildings is controlled by the FAA. And even in situations where different private parties, or here in Massachusetts, we're not allowed to take off from within any of our parks, um, even if we're not allowed to take off from those spaces, we're permitted by the FAA to fly over those spaces. And there's really no way that it can be limited through the FAA process. So any kinds of privacy limitations are based on you know, what the individual property owners would dictate, and they have some pretty serious limitations, in my opinion, as to how or what they can say. But ultimately, when we're flying with the drone, we're usually pointing the camera at the area of interest. So we're dealing with a property owner who knows that we're there and knows the reason why we're there, even if we're not the direct party related to that inspection.
Okay, I think that wraps it up. We're 1 minute over. Thank you so much, David, for this excellent presentation. It was well presented and very informative. Um, if anyone would like to see a copy of the presentation, is this something that can be shared, or do edits need to be made before it's shared?
No, you can share the copy that I sent you.
Okay, then we'll make it available on the listserv. Thank you so much, everyone. Remember to sign up for the next session. Okay, the link is in the chat.